So in this video, we're going to put together kind of everything that we've learned so far in terms of finding values of trig functions. So for example, let -3, 8 be a point on the terminal side of theta. Find cosine theta, secant theta, and the cotangent of theta. Okay, so I'm going to draw this point first. So -3, 8. So we're going to go out here to -3, and then we're going to go up here to 8. So I know it's not potentially drawn to scale, but that's okay. It's good enough for our drawing. So that point there is on the terminal side of our angle. So here's the initial side, and then here's that terminal side. So this is that theta, our angle. And so this is a case where we would be using a reference triangle. So I'm going to drop that down. This theta prime, right, that's my reference angle. And so since I went out here -3, and then I went up 8, and then I need to figure out what my r is in this case. So using the Pythagorean theorem, 8 squared plus -3 squared is going to be r squared. So 64 plus 9 is equal to r squared. And then if I add the 64 and the 9 together, I get 73 is equal to r squared. So r is going to be plus or minus square root of 73. But then remember, we always take the positive one when we're talking about the hypotenuse. So this is going to be the square root of 73. And so now I just have to figure out the trig functions we're looking for. So we're looking for the cosine of theta. So remember, cosine of theta is adjacent over hypotenuse. So it's going to be -3 over the square root of 73. Remember, secant is just the cosine flipped over, so it's going to be square root of 73 over -3. And I get asked a lot of times, like, where should I put the negative? It doesn't matter, right? You could put the negative down in front. You could put it on the top, on the bottom. So usually I just write it as this negative square root of 73 over 3. And then we need the cotangent. So remember, cotangent of theta is the adjacent over the opposite. So in this case, that's going to be -3 over 8. So we're talking about -3 over 8. So not too bad there. We'll do one more here. Let me get a good one and go to the next page. So we'll let 2, -3 be a point on the terminal side of theta. And this time let's find all 6. So find the values of all 6 trig functions. So again, I'm going to draw this first. So 2, so 1, 2, and then 1, 2, 3, -3. So we're talking about a point here. So that angle, right, starts here, it ends here, goes all the way around this way, right? That's my angle theta. So my reference triangle, I'm going to draw up to the y-axis, or to the x-axis. We're talking about this angle in here. This side here is 2. This side going down is -3. And then again, we have to use Pythagorean theorem to find r, right? So 2 squared plus -3 squared equals r squared. So 4 plus 9 equals r squared. So 13 is going to be equal to r squared. So r is going to be plus or minus the square root of 13. So in our case, right, remember we take the positive. So this is going to be the square root of 13. And then we're going to find the sine of theta, the cosine of theta, the tangent of theta, and then paired with the sine is the cosecant of theta, paired with the cosine is the secant of theta, paired with the tangent is the cotangent of theta. Right, so those are all the things that we're going to find. So the sine, right, is the opposite, square root of 3 over the hypotenuse. Or, sorry, not square root of 3. Opposite, negative 3 over the hypotenuse, square root of 13. So negative 3 over square root of 13. The cosine is the adjacent over the hypotenuse, so 2 over the square root of 13. The tangent is the opposite, negative 3 over the adjacent, 2. And then we're just going to flip these over, right? So minus square root of 13 over 3, square root of 13 over 2, and minus 2/3. One quick thing to kind of note, notice that on these problems, I did not rationalize the answer. That is fine. Alex will take the answer unrationalized. I don't expect you to rationalize the answers on the test. If you did rationalize the answers, it's okay, but you don't have to. So it's just kind of an extra step that I don't make you do.